Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on November 25, 2025, about 2 days ago. It introduces a purpose-built inference engine that makes long, interactive, physically realistic video generation far more efficient by using semi-auto-regressive block diffusion with language model-style key-value cache management. The paper is titled Inferix, a block diffusion-based next-generation inference engine for world simulation. And as we will see later, the implications for large-scale world simulation and real-time interaction are quite significant. Also, the authors shared a full Inferix codebase on GitHub. You'll find the core Python engine, installation guide, and requirements, plus example folders and configs for semi-autoregressive world models like self-forcing, Cosvid, and Magi-1. There is a model integration guide, tests, and LV bench resources for evaluation. Figure 1 shows why block diffusion is the sweet spot for long video generation. The top row depicts pure autoregressive decoding, which handles arbitrary length and key-value caching, meaning it stores past context efficiently, but cannot parallelize across frames. The middle row illustrates classic diffusion that runs many parallel denoising steps, but is stuck with fixed length and no caching. The bottom row demonstrates block diffusion, where each block is denoised like diffusion, while blocks connect autoregressively, so the system gains arbitrary length, caching, and strong parallelism for world simulation. Figure 2 explains how Inferix turns noisy video blocks into clean, streamable world simulations through a coordinated pipeline. This figure shows the block diffusion transformer pipeline at the top, which progressively denoises each video block while keeping them temporally linked. Below, interconnected modules handle attention computation, key-value cache selection and quantization, and then pass the resulting video to streaming and LV bench evaluation tools. Together, these components make long, interactive video generation both efficient and measurable. Table 1 spells out what actually goes into LV bench, which matters because the benchmark defines what kinds of worlds these models must simulate. This table shows 4 source video datasets, their video counts, and how many clips feature humans, animals, or environments. DanceTrack and Got10K lean heavily toward humans, while HD Vila 100M and ShareGPT-4v add more animals and environment content. The bottom row aggregates everything into 1,000 videos, with roughly 2/3 human-centric and the rest split between animals and general environments. Alright, the big takeaway is that Inferix turns block diffusion into a practical engine for long, interactive, physically grounded videos, with key-value cache management and streaming baked in. The second is that LV Bench gives a concrete way to measure real-world simulation quality. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.